Hello, Titans. I'm going to do a final little wrap up on that analysis from our lab where we were swinging a rubber stopper around our heads. We had created two graphs. I don't want to put these two together. I think I did this in my last video, but we ended up saying that velocity squared relates to the mass hanging, and velocity squared also relates to radius. Now, we also said, well, the mass hanging is pulling down. It's really gravity, the force of gravity pulling down on that mass hanging. So I hope it's okay to say mass hanging times gravity. The other thing that I included in my last video is the fact that the swinging mass, which we didn't investigate in our lab, although I've had students do this before. We include that in there. It would fit right there. So we put that together into this form. We said m swinging v squared over r equals m hanging gr. Whoops. Hanging g. And that we decided was like centripetal force equals mv squared over r. Okay, but I'm going to use that as a jumping off point to figure out how in the world do I figure out a percent error. So if I'm over here and I want a percent error, well, what do I do? We usually base our percent error not on our regression coefficient. That's just a number that tells us how straight the line was. We want to base it on something real from our data, like that. My slope is v squared over hanging mass. Can I make this equation look like that? Well, yeah. What would I have to do? I'd have to multiply by radius to get it to the other side. Let's see, I'm going to divide by hanging mass and multiply by radius, leave my gravity over there. I should also divide by mass swinging. I think I did that algebra right. There to there. Well, this is my slope. And it shouldn't be too tough to find a percent error. My radius happens to be 1 meter, most of us, although I think there were a couple of groups who used something different. But radius times gravity divided by the mass of the swinging should match our percent error, or should match our slope, I should say. How about over here? Well, I want my slope here to say v squared over r, rise over run. Can I make this graph say v squared over r? Well, yeah, mathematically, that's very easy. I simply divide by mass swinging. So mass hanging g divided by mass swinging. You knew your mass hanging. I think it was 50 grams, if I'm not mistaken. Of course, you know gravity. You measured your mass of your stopper. This represents your slope. And you should be able to find our percent error based on that. Compare this number to your slope. All right. Hopefully that kind of wraps things up. I know in that last video, I introduced the idea of centripetal force. Never talked about how to find a percent error. So hopefully that helps. Have a wonderful day.